Welcome, I'm going to take you through the AQA GCSE Unit 2 Computing Fundamentals paper. It's just computer science. This is the June 2015 paper. We need to zoom out. So I'm recording this ahead of the June 2016 exam period, and so the actual exam for June 2016 is on the 8th of June. It's a morning exam and it's an hour and a half, and it's after the half term in the exam period, so it gives you a bit of extra time to revise. It's the week after the half term. These are the grade boundaries for the last 2 years, so it's only been around for 2 years as I'm recording it now. It's going to be June 2016 and June 2017 when the course expires, and these are the grade boundaries for the last 2 years. You can see the first year was lower than last year of this paper, and that tends to be the case for almost every exam, because the first year there's less resources, you only have the sample papers to go on, and so people tend to do not as well as the years following it, so that's why it might be slightly higher. It's out of 84, which is slightly strange, slightly awkward amount of marks, but obviously it works out when they work out the UMS. So these are the grade bands you want to be looking for. I recommend you do this paper before you watch this video, because there's not too many papers available for you to practice. Okay, just to look at this front page in a bit more detail. Firstly, it's very clear that you can't use a calculator. Sometimes get emails about this, so you can't use a calculator. Don't even try and bring it in. Just cause a bit more stress than you need to. As I say, it's an hour and a half, so that's a good amount of time, I suppose. There's also a couple of questions where your quality of written communication will be assessed. I'm sure you're familiar with what this is from other GCSEs. It seems to be a component of all of them. And also, as I say, the maximum mark is 84. So let's begin with the first question. I've just pre-drawn my table in here because I knew I'd mess it up otherwise. And we've got to convert from binary to Deanery. So Deanery is decimal. That's how it's tend to be. So people don't tend to say Deanery, but the exam would want you to. So binary is base 2. The numbering system is base 2. This means we have 2 digits, 0 and 1, as you can see here. And Deanery is base 10 with 10 digits, and that's 0 to 9. So that's where it comes from. And so if you think about how to explain my table, and there's loads of different methods to do this. To be fair, if I was doing this in an actual exam, I wouldn't need to write the table down, because you get quite familiar with the orders, and you could with the columns, and you could just work it out in your head really. But for the benefit of the video, I thought I should at least draw it out. So if you think about how a decimal number is represented, or a Deanery number, if we have 125, what we're saying here, we have 5 lots of 1, 2 lots of 10, and 100 lots of 1 lots of 100. And you can see they get progressively bigger by 10 times. That's because it's base 10, all in terms of powers of a base 10. So 10 squared is 100, 10 to the power 1 would be 10, and 10 to the power 0 would be 1. And you can see with the binary columns it's the same. So this is 2 to the power 0, 2 to the power 1, 2 squared, and so on. And this is where the column headings come from, and then we double them each time. That's the same effect. So what I tend to do when you're converting from binary to Deanery is you write in your binary number into your table, and I explain this in the video. So if you don't know, there's a set of videos on my channel that cover this. There's also videos for different exam boards. So the AQA ones were made a couple of years ago, and the other ones are slightly more recent, so they might be helpful too. Anyway, so you write in your number, and then you essentially multiply the rows by the columns. So we have 1 lot of 128 plus 1 lot of 32 plus 1 lot of 16 plus 8, 0 lots of 4, 1 lot of 2, and 0 lots of 1. So we need to add this up, and that's going to be our Deanery representation. So if we add this up, we've got 10 plus 16, which is 26, plus 32, which is 58, plus 128 is 186. If I've got that wrong, I'll edit it out. But you've got to use a bit of mental maths. So this is the hardest maths you're going to get. Feel free to write it out more if you want to. Yeah, so it's only 1 mark. Bear in mind, there's not too much effort that should go into that. It shouldn't be too difficult. It's the first question of the paper. It should be trying to ease you into it to an extent. So part B is following on with conversions. Now we've got to state the hexadecimal representation of a binary number 1110. So hexadecimal is another numbering system, and this is now base 16, and so we have 16 digits. We have 0 to 9, which is shared with Deanery or decimal, and then we have another 6 digits that are separate. So we have A, which represents 10, B representing 11, C representing 12, D 13, E 14, F 15. And you've got to remember, it's base 16, but we don't go up to 16 because we have 0, 2. It's very easy to forget about 0. So these are the 5 kind of special digits we have in hexadecimal. So they're letters, but they're representing numbers. That is the worst box I've ever drawn in my life. Okay, so again, similar kind of method, except we have to basically convert to Deanery before converting to hexadecimal. There is in fact, I'll hold off saying that. So again, we only have 4 bits here, so we have 1, 2, 4, and 8. These are our column headings. And then we can write a number in. Let's do it in a different colour. So 1, 1, 1, 0. And now, same method to convert to Deanery, we just multiply it up. So this is just 8 plus 4 plus 2, which is 14. And then we can see here that 14 in this is effectively Deanery, and this is effectively hex, is E. So E is our answer. And sometimes we put a little suffix down here just to show the base. So this would be base 10, this would be base 2, but I don't think this is on the AQA specification. So what I was going to say before I cut myself off was that hexadecimal is used because it's more convenient for long strings of binary. I'm sure I explained that in the video, but what I might not have gone into was that the reason why we use hexadecimal, as in we use base 16 rather than base 15 or base 20, is because we have this relationship with binary. So when we have 4 bits, we can represent 2 to the power 4 combinations. So this is 16. When we have 1 hex digit, so bits stands for binary digits, by the way. With 1 hex digit, not an S there, we can represent up to 16 things. So in the same way that we can represent 16 things with 4 binary digits, with 1 hex digit we can represent 16 things on its own. So that means if we had, in fact, let's just take the one, the first question. This isn't really relevant to this question, but this is meant to be kind of revision too. So what is it? 1 0 1 1 1 0 1 0. The reason we often write them separated in nibbles is because we can convert this very easy to hexadecimal. So if we were asked to convert this to hexadecimal instead of what we were actually asked, we would just convert this. So this is 10 in binary. Sorry, no, that's 11 in binary. So when you do it in your head, you've got to be a little bit careful. This is 10 in binary. That's more recognisable. And 11 in hex is B, and 10 in hex is A. So this number 186, as we worked out, is BA in hexadecimal, and this is the way you'd convert it quicker. So you could convert this to 186 and then convert 186 to hexadecimal. This is the quicker way to do it. You separate it into each nibble, into each set of 4 bits. Part C is 2 marks. The first 2 parts were a mark each, and now we are also converting from hexadecimal to Deanery. So again, I'm going to use a table, but now we have different columns, but it's the same idea. So we now only have, well, we only have 2 digits. The maximum you're going to get with hexadecimal is 2, because that goes up to 258 maximum. So I want to write this in. So 4C, and for column headings, it's always going to be 1. So whatever base it is, the far right column, this is the least significant bit, is always going to be 1, and then this is 16 to the power 1, which is 16. So it's the same kind of idea. We just multiply up, essentially. But the only thing we've got to be careful is that C equals 12. You obviously can't multiply C on its own, but remember C represents this 12. So 4 times 16 plus 12 times 1. 4 times 16 is 64, plus 12 is 76. So our answer is 76. Right, move on to part D. It says place the following quantities in order of size, 1 to 4, where 1 is the smallest and 4 is the largest. And so we've got 15 bits, 3 nibbles, 2 bytes, and a kilobyte. So the kind of information you need to know to answer this question is that, firstly, that a bit is just 0 or 1, stands for binary digit. We have the next, a nibble, that's 4 bits, so 4 bits. We then have a byte, which is 8 bits, or 2 nibbles. Then we have a kilobyte, and a kilobyte is a bit of a tricky one because I was certainly taught that a kilobyte is 1024 bytes. However, in truth and technically it equals 1000 bytes. That's because kilo is this prefix, and this means times 10 to the power 3, so times 1000. So we think about in physics, so you have a kilogram is 1000 grams, a kilometre is 1000 metres, so it's kilo means times 1000. The problem is, and the reason this issue kind of came about is 2 to the power 10 is equal to 1024. So the closest binary number to 1000 is 2 to the power 10. And so the person obviously who decided this convention decided, okay, 1024 is close to 1000, so we're going to adopt the kilo prefix, because obviously kilo is in terms of base 10, this is the base of 10. So it's a bit of an issue here. So really, kilobyte, for technical definition, is 1000 bytes. 1024 bytes is used a lot, and I think I talked about this in the video, or maybe I didn't, but I think I definitely showed you that it's 1024 bytes. But I would probably, especially because you haven't got a calculator, I'd probably stick to using 1000, because it's obviously easier to do any calculations with in terms of 1000. It doesn't affect this question at all, but I thought it'd be worth mentioning. So if you want to know, so 1024 bytes, the actual technical thing is a kilobyte. This hasn't really taken off. I think it was introduced sort of 1998 or something, but this prefix hasn't really come into general use, so there's a bit of dispute between which definition it is, but regardless, it isn't really relevant to this question actually. So I would recommend you just convert to the lowest unit for this. So we have 15 bits here, it says that already. 3 nibbles, if we want to put it in bits, is 3 times 4, so 12 bits. 2 bytes is 2 times 8 bits, so that's 16 bits. And a kilobyte, well, let's just stick with 1000 for now, but obviously it doesn't matter because it's by far the largest. So first of all, we can just put this as 4 being the largest. Smallest is this, 3 nibbles. Second smallest is 15 bits, so this is 2, and then we have 3 here. It should be a really easy 3 marks. Part E is about Ascii. It's only worth 1 mark, and it says Ascii is a character encoding system. You might also have heard of it as a character set, same thing. It uses 7 bits to represent each character. Extended Ascii, the latest version, uses 8 bits. When it asks us to complete the table stating a binary representation of a character G. So it gives us the character code for F, and if we weren't given this information, I wouldn't be able to answer this question. I don't know the ASCII codes off by heart, but the thing it's trying to test here is that you understand that the letters in ASCII are consecutive, so they're stored consecutively. So the character code for a letter is 1 less than the character code for the letter after it in the alphabet. So G is the letter after F in the alphabet, where we then have H. So the character code for G is going to be 1 more than this in binary, and then 1 more than the previous one if we had to do H, but we don't obviously. So basically we just need to make sure our binary number is 1 more than the one for F. And you could, so there's something called binary addition, which is not on your course, you could do that, but remember this column is the ones column, and we haven't got a 1 at the moment. So if we just change this 0 to a 1, it's now 1 larger. So that's all you have to do. You don't have to do any other conversions. You could obviously convert it out and do a couple of stages, but that's not necessary. So we change that to a 1, and that's our 1 mark. F says the following grid represents a bitmap image where black pixels represented using the bit pattern 0, 0, and the white pixels represented using the bit pattern 0, 1. So this might not be how you expect it. Usually it's just 1 and 0, but this is obviously just making sure if you take in this information, the binary encoding of each row is shown next to the image. So we can kind of see the pattern here. So 0, 1 is white, so you've got 2 white pixels here, and it's reading from left to right, as we can see from this example. So that's the thing we need to take from this little example, and we need to basically follow the pattern. So it gives us 3 images and it asks us which one of the following images has the correct encoding. So the first one, let's just remind ourselves, so 0, 0 is black, and 0, 1 is white. So the first 2 pixels here, we're reading from left to right. First 2 pixels are black, so we should get 2 0 0s. We don't, so this is automatically out of the question. The second one, B, we have a black pixel here, we have to look at it in pairs. We then have 2 white pixels, but we then have another black pixel that's missing off the end here, and the same for bottom. So this is correct up until this point here, and so that's going to make this wrong essentially. But if we weren't sure, we could just look at the third one. So if the third one was wrong, we'd probably say this is the correct one, but the fact for the third one, if we see here, so first pixel is black, we've got 2 0 0s here, it's fine. Then we have a white, then a black, and the bottom row is fine as well. So this is perfect, there's no issues with this. This is the issue here that's going to cause us a problem. If it was on its own, it'd be fine, but we've got this extra 2 columns here, which is going to effectively make it not for correct encoding. You can't just run over your allocation in binary, you have to be very strict. If you say you're going to use however many bits this is, 12 bits, you've got to use 12 bits, you can't use another 4. So this is the wrong one, this is the correct encoding here. FII says state the maximum number of different colours that can be encoded when using 2 bits for each pixel. So basically, how many combinations can we get using 2 bits for each pixel? So I talked about this earlier actually unintentionally, I didn't realise this question was coming up. So I said something like 2 to the power 4 equals 16. So when we have 4 bits with base 2, because it's binary, we can have 16 combinations. I was talking about this in relation to the relationship between hexadecimal and binary, and this is just a general idea. So when you say the question was something like, if we had 2 Deanery digits, how many numbers could we represent, or how many colours could we represent using this? And so it'd basically be base 10, so we write 10 down as our base, and then we have 2, so 10 to the power 2, and this is 100. If you think about it, with 2 digits we can represent numbers 0 to 99, which is 100 numbers. So this is the number of combinations, and this is sort of a general rule. So when we're talking about base 2, and we're talking about having 2 of them, is literally just base 2 to the power 2, because we have 2 bits, and so this is 4, and so we can have 4 colours. We have 4 combinations, and each combination can represent a colour. Just to prove this to you, with 2 bits we can have 0 0, which could represent a colour. This is representing black in our example. We then have 0 1, 1 0, and 1 1. So we can have 4 combinations with 2 bits, just to prove that this is true. And FII is continuing this theme, I suppose, checking it wasn't a fluke if you got the first part right. And it says state the minimum number of bits needed to encode 32 different colours. So basically we're saying 2 to the power x equals 32. And there's a mathematical way you can work this out, but you need a calculator, so we're not going to go into that. It's not very difficult. If you think about it, so we've got 2 squared, we've said that's 4, 2 to the power 3 is 8, 2 to the power 4 is 16, and 2 to the power 5 is 32. So this is our x value, which we're kind of solving for. So the answer is 5. The final part now says to state one factor other than the number of bits used to represent individual colours, which we've kind of been talking about. This is something called the colour depth, by the way. Not something you need to know about, but just thought I'd throw it in there. That can affect the quality of a bitmap image. Just to, I should have explained it earlier really, but a bitmap image is just an image stored as an array of individual pixels. So pixel is actually kind of a tough thing to define, but really it's the smallest distinguishable feature you can determine. So just like a dot that makes up for your bitmap, essentially. To be honest, my first on what I would write if I was doing this would be compression, because we have compression on images, but I don't think compression is on your course. So the second answer I'd put would be the resolution. The resolution is the detail of the image whole, so really the more pixels you have, the higher quality the image is, and so a lower resolution would reduce the quality of the image. The mark scheme actually does say compression, interestingly, but the rest of them, resolution, number of pixels used, size of the grid, PPI, which stands for pixels per inch, are all the same idea. First part of question 2 says items data can be combined together to form a data structure. State the name of a programming language you're familiar with, so the one you've learned in class. So this could be Python, Java and C are also listed on the mark scheme. Give one example of a data structure that can be used in that programming language. So obviously I actually don't know the list of programming languages available to you. If I first show you just what the examiner report says for this, I recommend you read the examiner report. It's not just for computer science but for all your subjects. It can be really useful. And it says that actually this was answered correctly by less than half of candidates, which is not brilliant when you think about it, because it shouldn't be that hard. You should be, I suppose people don't, as soon as you finish your controlled assessment, maybe there's a tendency to forget about it and just concentrate on what you think is going to be the most typical theoretical exam content. But this is, I guess, a fair enough question to ask, because it shouldn't be too difficult. So the mark scheme gives some examples. I can't cover all of them obviously, but if you just Google your language and a list of data structures, or just Google Python list. So it says here, I don't really know what this means. I assume this means award. I'm not an examiner, there's not like a key, but I assume this means award. So if you didn't write a programming language and you just wrote one of these options, you can still get it right. So if you wrote Python and array, so there aren't any arrays in Python technically, they act very like lists, although in a theoretical sense an array tends to be homogeneous, which means they all have the same data type, whereas a list tends to be a bit more flexible, but the actual implementation does vary. So if you wrote Python and array, I don't know if you'd get marked down. I imagine you probably wouldn't, because the language doesn't matter so much. It's probably there to help the examiner. But yeah, it's only worth 1 mark, so I'm not going to fill this in. Let's move on. We're now told that a programmer is developing a program that needs to record the names and ages of a group of students. Give 3 advantages of using data structures to hold this information instead of using individual separate variables for each name and age. So the first, I suppose, obvious advantage is that it's, in a general sense, more beneficial to hold this information together. So instead of having a separate variable for each name and age, you can just store both of these together in the same data structure. So a second advantage is we're not told how many students we have in this group. It could be 5 students, it could be 10, it could be 50, it could be a range of students. The program could be constantly updating. And if we have a separate variable for each name and age, it'd sort of be like, okay, name 1, name 2, but we don't know how many it's going to go up to, which I can't think of how you would program that. Whereas if you had a data structure, some data structures are implemented quite strict, so you might have to declare how long, how many elements are going to be in your data structure, but not always. They can be quite flexible. So if you had 5 students first and then you had 10 in the next execution of a program, then all you'd have to do is just add it on to the end of the data structure instead of having to create 5 variables from somewhere, which might not even be possible. So we don't know how many students there are going to be, and the data structure makes it more flexible. So I've just said actually a data structure would allow any flexibility. So if this number wasn't fixed, then it would just allow a bit more flexibility. We can just add on extra numbers and extra names and ages just onto the end. So my third advantage was going to be that it's easier to reuse the code, which is, to be fair, basically the same idea as advantage 2, which is a little bit tricky. So I looked at the mark scheme, and actually a good point they say is that it's easier to iterate over or /transverse. It says to do that over a data structure. It's very difficult to loop across different variables, as hopefully you can picture. So it's very easiest to loop through the data elements using sort of like a parameter. So this is a little bit of a tough question, just because it's difficult not to repeat yourself. It's difficult to have 3 distinct advantages, but make sure, there's no point just writing essentially a repeat of your previous point, your previous advantages, because you're not going to get marks for it. So try and do something distinct, even if it doesn't seem as obvious. So we'll start with question 3. It says to define the term algorithm. So a bit of exam technique here. It's really important to see how many marks you're going to get allocated before you write anything, because so an algorithm is a set of instructions, but you're not going to get 2 marks for saying that. If you think about how they're going to decompose this definition of the mark scheme, you're not going to get a mark, you're going to get 2 marks for saying a set of instructions. So there's also going to be a second part to this, because this is just 1 point. And so with an algorithm, they're designed to solve a problem. and this is our 2 marks. So hopefully you can see what I mean. You've got to be thinking about, so an algorithm could be a really short definition. If it's a 1 mark, you know, you might get away with just saying a set of instructions, but 2 marks you need a bit more. And if it was a 3 mark question, then maybe even more than this. But this is sort of a full definition of an algorithm. It doesn't have to get too much more complicated. Okay, sticking to the same theme, we're given 2 algorithms and both of them have the same purpose. And this is written in pseudocode, by the way. Pseudocode is just a high level, sort of informal version of code. It's never going to get executed by a computer, so the syntax doesn't matter so much, and you don't have to stick to any convention. Just make your pseudocode simpler than how you'd probably program it, but we'll write some pseudocode a bit later. One important point is that the array indexing starts at 1. Often we do 0 indexing, especially when it's implemented in programming, in code, but this is starting from 1, so just bear that in mind. And also, just to pick up on this pseudocode, so AQA have their own convention. I'm pretty sure it's publicly available, it might be on their website, but they use this arrow to represent assignment, variable assignment. So that's what that means. It doesn't mean anything too special, but often we use equal signs, especially when we're doing it in code. So, the completed trace tables for both of these algorithms are shown below when the array is this. So we have 5 elements. So we basically have to complete. Oh no, we don't. They're completed for us. My bad. And we're asked to. Both algorithms use a variable called I for the same purpose. State the purpose of variable I. So presumably these trace tables are here to help us. Well, we can see that I is increasing by 1 each time, and yeah, so I is often used as sort of a temporary counter for the loop. So as you can see here, we're basically increasing, so I is assigned here, we're basically increasing it every time we loop through this until it's going to be 5. So as we can see here, it stops when it becomes 5. Yeah, so I is this, I wouldn't say temporary in the exam, but it is there to count through the loop. In fact, the mark scheme says for the array, which is a much better way of putting it, although it is in brackets, so you'd probably just counter on its own would get you marks. Also index or stepper, but it's for the array, but this is in brackets, so I was probably incorrect to say for the loop, but there you go. We're now asked to say what the data type of a variable matched is. So where's matched? Okay, so it's matched equals false, and false, true or false is a Boolean value. So the Boolean data type is either going to be true or false. So that should be relatively easy if you've learnt the, I think, 5 or so data types you have to know. So it's Boolean. So as it says, they both have the same purpose. State this purpose. So let's have a look at what they're actually doing, because we haven't really touched on that. So first of all, we are assigning diffie to the variable a, and diffie is an element in this array, and we're automatically saying that it's matched false, so that gives us a clue what it's going to do. It seems like it's matching up, or trying to find if diffie is in this array. That would be my first guess. So it's incrementing I as we go through, and it's using I to index this array. So we're starting counting from 1. Firstly, it starts with a 0, then we made in the first line of this body of a loop, we make it 1. So if array 1 equals a, then matched equals true. Okay, so it's basically checking whether a, or in this case diffie, is in the array. So let's just check this is the same. It should be. It's just doing it slightly differently. So yeah, we're basically checking that diffie / a is in the loop, is in the array. So yeah, to check whether diffie / a is in the array, not the loop, as I said. Give one reason why algorithm 2 could be considered to be the better algorithm. So as the trace tables nicely demonstrate, it does this process a lot faster. So it's only really, I mean, looping 3 times, I suppose you could say. And yeah, so in terms of lines, it's the same, but this would be described as being more efficient because it does this process using less loops. So I think it's only worth 1 mark. So probably efficient would be a sufficient reason The mark scheme goes into a bit more detail, which you can pause the video and read if you want to, but it does say it's more efficient. This is the simplest answer, to be honest. Part A of question 4 begins with this nice diagram. It's the waterfall model of the software development lifecycle, and we have to write the appropriate stage in the corresponding box in the diagram. And the software development lifecycle is just, well, to be fair, it's literally what it says on the tin. It's just the stages that software has to go through before it becomes publicly available, whether that's going to be sold or perhaps even open source. So stage 1, we've given these 4 options here. So the very first one is analysis. We have to analyze the requirements of the software. So this is when we sort of discuss what the end user needs. The second stage is the actual design. So we are designing it based on the analysis, which was in stage 1. We then have to actually implement this, to actually do the coding. Then we have to extensively test it. There are also other stages you might have seen, like feasibility, which sometimes goes in before analysis, and you also have evolution or maintaining as sort of like a stage 5, which is just when you sort of update the software, but these aren't the ones we're given. And I think you could probably, even if you didn't know anything about this, you could probably use a bit of common sense perhaps. State another software development lifecycle model. The 2 other options for you doing this course, for ones on the specification, are the spiral model / the cyclical model. I mean, obviously you have a waterfall model too, so there's 3 of them in total. So you can write either of these and you get your 1 mark. I'm sure there are others, but these are the ones on your course. So these are the 3 images I thought I'd just quickly show you. This is meant to be not just telling you the answers, but also do a bit of revision too. So the spiral, also how we have the waterfall, as we've seen. So these are 3 you need to know. Pause it if you want. There's a couple of extra steps thrown in here too, but these are ones you could get examined on. So now we have the first of the quality of written communication questions, which are always very fun. We're asked to explain the advantages and or disadvantages of using prototyping when developing solutions, and you must also include a description of what prototyping is. And as I say, it's a quality of written communication question, so just to show you what you get for marks for, or sort of a general description of the marking range. We're obviously aiming for a high mark range, which is 5 or 6 marks. So as it says, you must give this description. It's very clear, and interestingly, you only need to say 2 or more correct advantages, disadvantages. It's not like you need to do 6 points. It's not a mark a point type mark scheme. It's more holistic. So that's what we're going to aim for. We'll do a couple, obviously. Just do a little plan. So first of all, let's just say what prototyping is. I'll write this up in a minute. Prototyping is really creating or giving a client an opportunity to see a project before it's actually completed. Okay, so showing a client the product before it's finished. Apologies for the awful handwriting. I mean, we're talking about this in terms of programming projects, but prototyping applies with just development of anything really. So just to do the advantages, so it gives an early indication of whether you're actually going to meet the client's expectations, and it means that the client can change anything they don't like or anything they think isn't being done well. If they change their mind on something, it can be done at this early stage. So as I say, it gives a nice indication of how the project is coming along, and the client can change things at this early stage if they feel like it. Towards the end of the coding process, at the end of the implementation stage, if the client wants to change something, that's going to massively change the timescale, and with a lot of cost too. So doing this at the early stage, the earliest possible stage, is ideal. So just a third advantage, you don't really need to do another one, but it might make, so the client might be describing things to the programming team or the team designing this system that doesn't really make sense, whereas if a client can see this program or feel this tangible object, they might be able to best describe what they want to change. So that's sort of a third advantage, but it's a bit wishy-washy, probably not concrete and not something I'd want to write. In terms of disadvantages, the effort that has to go into actually making a prototype. If they have to go out of their way to make the prototype, then that's a bit of a waste of time, potentially, if you don't think the advantages are that strong. There might be too much expectation on the prototype. The client might think that the prototype is going to be exactly the same as the final solution. So that's probably enough. I'm just going to type it up. You don't really want to see me write all of this out. You don't need to write much. It's got a whole page of blank space here, which is kind of unnecessary. I wouldn't suggest you write this much. If I was doing this myself personally, I like to do little plans when I'm doing longer mark questions, just because, especially because your written communication is getting assessed, you don't want to waffle too much, you don't want to be too unstructured. So I just write the description, then advantages, disadvantages, and you're good to go. Really, you're going to get your full marks hopefully. So I'm just going to type this up now. Right, so I've had to copy it in from Microsoft Word, which is a bit awkward, but I tried to spend about 5 minutes on it, which is a realistic amount of time, perhaps slightly less than that because I'm typing it up, but that gives you about a minute or so to do a bit of a plan and jot down of any notes. So you've got my definition here, which is I guess also sort of continue, because the fact that it's incomplete and might not function is sort of part of what a prototype is. We've then got, I've kind of merged it with a disadvantage. It might give them, they might have too much expectation and they might expect it to work fully, which would be a disadvantage. It might be a pain for the programming team to try and explain this to the client. So ideally it can allow them to update, and the cost and effort will be smaller than if it was left later on, but it might also be distracting and costly, which is obviously undesirable. So it's not a brilliant answer. Your answer obviously doesn't have to be that good either. To be quite blunt, it's not going up for any awards, it's just trying to get you the 6 marks. So I think the takeaway from this is that you don't have to write 6 points, 6 advantages, or 3 advantages, 3 disadvantages to get the 6 marks. You know, you don't have to write a ton. Don't spend 10 minutes writing a whole page worth on prototyping. It's not worth it. Question 5 is on relational databases, and we're given 2 tables, airport and country. And first question, first part is, which one of these 3 fields in the table country with a primary key? So I'm actually going to stop and get a image which should help with this. So this table I've just got is something that really helped me when I was learning about databases. This is from quite a popular textbook. I think it's called something like Database Systems. And one thing that really confused me when I was first learning about databases was the amount of terms, and it seemed like everywhere I was looking there was a different term being used. So this kind of shows you alternative sets of terms that can be used. So an attribute is the same as a column, is the same as a field, table might also be called a relation, a row is the same as a record. So this might be useful for people who are also confused about terminology, because it is a pain in some areas of computer science where there are so many terms that relate to that are the same thing essentially. So that can be a bit confusing. You might want to use this table. So a field is the same as a column. A column is probably a lot easier to remember than what a field is. So which one of the 3 fields in the table country will be the primary key? So a primary key is something that's used to identify a table, and we can then link it to another table with a foreign key in that table. So a primary key has to be unique. So a primary key needs to be unique. So which of these, which table we're using country, which of these fields, which of these columns is going to be unique? Well, firstly, currency isn't unique because Germany and Italy have the euro. The time zone also have the same time zone, so that leaves country name. Every country has got a different name, so that's unique. AII says, how many records are there in the table airport? Well, a record is the same as a row. You might remember it anyway, but this means we have 1, 2, 3, 4, 5, 6. So 6 is our answer. We now have to go a bit beyond just counting and now have to describe how a relationship has been created between the table airport and the table country for 2 marks. So this goes back to the fact that we have this shared field. So we have country name here and we have country name in the country table. And so this is our, so if we're focusing on the country table, this is our primary key, as we've said, and it's connected to this foreign key in the airport table. If we're looking at the other way around, so if we're looking at in terms of the airport table, the primary key is country name and it's linked to this foreign key in the country table. So it depends which way you're looking at it, but really we have a primary key of the country table which is also in the airport table, which is the foreign key. So that's how they're linked. The terminology is a little bit difficult to get your head around, especially because you can flip it depending on which table you're looking at, but really the idea is that we have the same column in 2 different tables. This is a more technical definition. The primary key of a country table is the foreign key of the airport table. As I say, you can flip it, which is a bit confusing at first, but this would get us the 2 marks, I think. You could also just say that they share this same field or same column, but this is the better answer, I suppose. We're now given this table and we have to put a tick next to the correct SQL statement that will add Stansted Airport, which has this code and one terminal, into the airport table. So first of all, we've got put into airport value Stansted SDN UK1. Well, firstly, SQL put into isn't an SQL statement. If it was pseudocode, that'd be fine, but this is not a programming language, this is a query language, but that's not going to be in the syntax. Hopefully you should realise that you should eliminate that pretty quick. The next one is updating airport, and this all looks fine to me, except that if we go back to our table, we haven't got Stansted in the table already, and to update it, updating is there to amend what you already have, so change the record you already have. So we could be updating, say, Manchester Airport, because it's already in the table. We haven't got Stansted in the table. We're talking about adding it to the table, so we have to use the insert into statement, which is our only option we have left, so we tick this box. For part C, we have to list the results of executing the following SQL query on this relational database. So it's worth 3 marks, so we're going to have 3 stages basically. So first of all, we've got to select the right fields from the right tables. It's going to be from both tables. This is what this from line is. So airport.code, so we're using the code field and the terminal field. If we go back to the table, so the airport, we have the code and the terminal field, where from the country table the currency equals euro and the country name equals the same as the airport country name. So because we have this AND operator, both sides of this, so the currency has to be euro, and this is basically just saying that it needs to be in both tables, it has to be both for it to apply. So it has to be euro from the country table, so Germany or Italy, and Germany and Italy appear 3 times, and this is 2 for Germany, 2 airports, 2 German airports and an Italian airport, and we're asked to select the field from this condition. So it has to be euro, and it has to be for code and terminal for Germany, Germany and Italy. So we have Frankfurt, FRA, has 2 terminals. It tends to list it with a comma when SQL queries this. We also then have Hamburg, ham, 2. We then have this airport, which I can't pronounce, FCO, and has 4 terminals. But we're not done here, because we have this final line, this order by line, and so the order command is used to sort the results, essentially coming back from a query, and this keyword here is ascending. If you had descending, it would be DESC, I believe. So we're making our results ascend using the code. So the code is FRA, etc., not the terminal number. So if we were dealing with, if this was .terminals instead, this would be fine, because we have this ascending order with our numbers, but we're dealing with letters because we've got code, which is a string. So F comes before H in the alphabet, so we need to rearrange this. So H is going to go last. In fact, let's do it here. So which one of these is going to go first, because they're both F? So we now look at the second letter. In the same way that surnames are done on registers, they move along. So if you have the same letter, it will go to the next letter to sort it. So C is obviously before R in the alphabet, so this goes first, and then we have FRA2, and I've left a bit of my ink behind, but this is our kind of final answer. And this is a bit of a tricky one, because I don't know how you'd exactly get working marks for this. In fact, let me have a look at the mark scheme. So you get a mark for displaying the airport code before the airport terminal. I suppose this is important because it lists the airport code before the terminal. That's how I knew to list it like this, with a comma in between. Also, you get a mark for identifying the correct 3 records, even if the wrong fields are shown. I don't totally understand that point, but you also get a mark for displaying it in ascending alphabetical order. So that's where you get the marks from. The first part of question 6 is a very nice 1-mark definition. What is a computer system? Well, it's hardware and software working together. You could get away with just saying hardware and software, but that's okay. Part B is about the fetch, decode, execute cycle. So memory and the processor are two essential pieces of hardware. Explain with reference to both of these components how the computer processes instructions. So like I say, this is about the fetch. Well, decode is a step we don't always say, but it's a step. Execute cycle. So there's 4 marks. Basically, I'm going to aim for 4 points. In this question, this is one we want to be getting sort of a mark per point. Instructions. Loaded into memory from, it's not really relevant, but from the secondary storage, like the hard drive. So when they're going to be processed, when they're going to be executed, is now the fetch stage. So this is all about fetching instructions. From speaking to people and people asking me questions, there's a bit of confusion about this fetch stage. Some people think it's about fetching data, actually it's about fetching the instructions. So the instructions are fetched by the processor from the main memory if we go along something called a bus. So how are we going to say this? Before it can be executed, the processor loads the instruction from memory, or no, let's say fetches from memory. So I just thought I'd show you this diagram just so you have some kind of visualization of how this actually looks. You don't need to, actually for this course, you don't need to know too many details about things like the control unit or arithmetic logic unit. You just need to know the general stages of this cycle. So this is a bit extra, but basically they're directly connected through something called a bus. And so you have the main memory here, usually the RAM, and we have our sort of storage locations. We have cells in the memory where our instructions will be stored, and the processor fetches the instruction from this location and sort of brings it into one of these registers, which are small stores of data. But this is going a bit beyond what we need to talk about. So the processor then decodes the instruction, and this is essentially splitting it up into the opcode and the operand. So each instruction will have the instruction like add 10. So the operand is the data, the opcode is the instruction. And as I'm saying this, I'm pretty sure this isn't on your course. I'm going to double check when I edit, but this may be again extra information. I'll get a bit confused because I've covered a couple of courses on my channel, well 3 courses now, so they each have different levels of requirement, but this would be a 3rd mark. The final part of this cycle is when it actually executes this instruction. So execution just means basically following the instruction. Also, like running is the same thing when we're talking about code. So the execution stage is where the actual instruction is carried out based on what has been decoded, what has been worked out in the decode stage. So the decode stage is kind of like a planning stage. It looks up what the instruction is, looks up how it's meant to deal with it, and then the execution stage is actually following the instruction. And that's it, that'd be our 4 marks. There are some extra points here you can pause and read, but the 4 main ones are the ones I've done for most logical ones. Now we need to give one reason why a CPU with 2 cores might perform faster than an equivalent CPU with only 1 core. Well, this is because when you have 2 cores, essentially it's like having 2 CPUs. It's not quite the same, but if the code is optimized, if the instruction is optimized, if the operating system is optimized, maybe it can process, in this case with 2 cores, 2 instructions simultaneously. In parallel is probably the more familiar term, but the may here is quite important, because if the code isn't optimized, if it hasn't been designed for parallel processing, because not all programs are going to be designed to be processed in parallel. A lot of CPUs now have many cores, but you need to have an algorithm that's actually going to work with it. For 6D, we're shown 6 different types of memory and storage. Storage tends to be non-volatile, persistent storage, whereas memory on its own tends to just mean main memory, which is volatile. Volatility is about, in fact, is there a question on volatility? I'm not sure. The volatility is about whether data is retained when power is switched off. So a volatile device like main memory, when it's switched off, when power is cut, when your computer's turned off, the data is lost. Whereas something like a hard drive, which is non-volatile, which is an example of magnetic media, you're not going to lose your data when your computer's turned off, fortunately. Whereas RAM, for main memory, will lose it. It's only really for when the computer's on. So for each of the descriptions in the table, write the label of the type of memory or storage it best describes. So first one uses a laser to read the data. This is optical media. So this is like a DVD, a CD, and it works by having like pits in the disc, and the laser, this is awful, but the laser can shine through, and if it bounces off at weird angles and isn't received, then that we usually represent a 0, I believe, but if it bounces back, it will represent a 1. So that's what optical media, that's how it works. The second one, contents cannot be edited. Well, that's ROM. So ROM stands for read only memory. So that means you can't, once you've stored something on ROM, you can't change it. And this is true to an extent. There are some cases where you can extract or just alter the data stored on ROM, but ROM is usually used for things like storing the bootstrapping program, the program that starts up your computer, so it will load the operating system into the memory. Also, it might contain, ROM might contain firmware, so that's software that's very closely tied to hardware, so hardware doesn't need to get updated that much. So you might have a couple of bits of ROM in your computer that just do small things like that where you don't need to change it, but it wouldn't be very useful for most things. So that's what ROM is, quite distinctive. Small and very fast storage found close to the processor. This is cache memory. So cache memory is, like it says, a small and very fast storage found close to the processor. This is called CPU cache in particular, but you can also have cache like browser cache. So your browser, Firefox, Google Chrome will have a cache for loading frequently accessed websites like Google, YouTube, and they'll load a lot faster because they're stored in this very fast cache. So another question to do with cache might be, what kind of data does it store? Well, it stores things that are frequently accessed. So things like, for the CPU, instructions that are frequently accessed, because it saves it having to go. So if you remember that, it's good if I showed you that now. Say this is the CPU, we have our buses that connect to the main memory. Well, the cache memory is usually somewhere on the CPU or very close to it. There's this distance to get to the memory. The memory is very close, whereas if you think like the secondary storage is a longer way away, so it actually physically takes more time to get to. It will go through other input-output channels. But the cache memory is actually located on the CPU. It's very close. It's very fast to get to. It's very fast itself, but the latency is small compared to the main memory, which is not exactly long either. But it will store frequently accessed instructions to try and speed up processing. The next question is talking about virtual memory, which is something that happens, it's a sort of more of a process that happens when the RAM gets used up, or the main memory. RAM stands for random access memory. So say you had hypothetically 4 gigabytes of RAM in your computer, which isn't a massive amount, it's sort of, I guess, the average amount of RAM someone might have. This could get used up. So if you had loads of programs open, for some reason loads of stuff was in the memory, then it could run out. And so when you try to open something else, when you try to do something else, it physically could not store any more data in the RAM. And so virtual memory is kind of a procedure that happens when it runs out of memory. And this is kind of a situation it's talking about. So when the memory is all in use, or run out is a bit colloquial, not very technical, memory is all in use. And this is what it's asking. It's not asking what virtual memory is per se. But virtual memory works by essentially using a bit of a hard drive. So say this is your hard drive. It will allocate a bit of a hard drive space for spare capacity as this virtual memory. So it's stored. This extra data stored in for secondary storage instead of for RAM, which just takes longer to access basically. The read-write times of secondary storage isn't as fast as RAM, and it takes physically longer to access. So it's not as fast, but it's better than running out of memory. For question 7, we're given the following function which calculates the second-hand price of different models of car. The parameter condition is an integer with a value between 1 and 4, where 1 is excellent and 4 is bad, very bad. So it's putting a value on the condition of a car. So quite a long function. Part A says function and in function are keywords in car price, which is the function name. And these indicate that it's a function. Whichever keyword, singular, indicates that this is a function. So a keyword tends to be capitalized in pseudocode. That's certainly what I do when I write pseudocode. So as it says function, very clearly it says it's a function, as does end function. It gives the game away a little bit. But what other keywords here, so capitalized words, give away if it's a function? Well, if, else, else, end if, and so on, case are all to do with conditionals, whereas return is the only other option anyway. A function in its theoretical sense and in most implementations has to return a value. So that's what a function in maths is, for example. So a return value is sort of what makes it a function instead of something like a procedure perhaps, or another subroutine. So for return keyword is the answer here. Okay. Part B asks us to tick the most appropriate data type of the variable cost. So we're given boolean, character, real, string. Character is just going to be something like a. Usually it's done in singular quotes. A real is a decimal number, so something like 1.5. Perhaps it doesn't actually have to be, it could be any number, but it allows it to be 1.5. It allows it to have a fractional part. String is just multiple characters, and boolean that we've looked at earlier is just true or false. Let's just put true there. So we're asked to look at cost. Anyway, you can probably guess what cost is going to be. The only numerical data type here is real, but anyway, we're dealing with so this could be a string. So say cost equals 400 could be a string. It's not actually, because we haven't got brackets around it. Haven't got quotes around it, sorry. But the fact that we have to then do a little bit of a calculation here, we have to use the value of cost to find a new value of cost. You can't do a subtraction with a string. You could only do it with a numerical data type. And the only numerical data type here is for real. If it was an integer, then all of the values here are integers, except we actually have to divide it, so maybe that wouldn't work. But the answer here is real. For C, we have to complete the trace table below, showing the changes in the variable cost when the function car price is called with the following arguments. So the difference between arguments and parameters is the parameter is kind of like the variable. So what was the one it gives? So condition is an example of parameter, so is model and age. These are the variables. These are kind of placeholders for the actual arguments, which is the actual data being passed to the function, which is in this case tidy 4 and 2. I don't have to keep scrolling, so I've copied the trace table across. Trace table is just used to show the values of a variable throughout the execution of a program. So we have to fill in 4 boxes here for cost. So first of all, straight away, regardless of our arguments, cost is 0. So that's going to be our first one. Hopefully you should get that. Then we have to actually use our arguments. So if the model, which is the first parameter, so tidy is the argument. If the model is daily, then the cost equals 6,000. Is not, it's tidy. Else, if the model is minty, then it's 4,000. It's not, it's tidy. Else for cost equals 2,000. So that's the next one. Else just means anything other than these 2 options, and tidy isn't listed as one of these if or else statements, so it's got to be else here. So we move on to using a case statement here, or case condition, and this is technically a multi-branching conditional with well, in this case 4 choices. So really it's very similar to an if statement, except we're given essentially as many choices as you need. You're not limited to just doing if and else. So we're using a condition, so this is the second parameter, so the second argument, which is 2 in this case, which is 4, not 2. So we if condition of 1, 2, 3 and 4, well, we've got 4 here, so we're looking at this line right here. If it was 2, it'd be this line, 1 and 3 and so on. So the cost equals the current cost minus 1,000. So the current cost of this stage is 2,000, so this is 2,000 minus 1,000, which is 1,000. So you should be familiar with this kind of formula, but this just means you use your previous value and then do something to it to make the new value of itself. So it's a bit confusing, but it's quite common in programming. And then we have to use this cost, which is now 1,000, divided by age, which is 2, and we get our final answer, we get our return value, which is going to be 500. But we still have to fill this in. So we get a mark for each row, and there's only 4 distinct things happening here, so I don't think this should be too difficult. Now we have a very similar question to the one earlier. We have to state 3 advantages of using functions/procedures when developing a program. So these are called subroutines or subprograms as like a general category. These are the 2 we generally talk about and you need to know for your course. So say functions, especially when you compare it with procedures, functions return a value whereas procedures don't necessarily. So 3 advantages of using these. Well, you could it's very good to use them because it prevents repetition in your code. If you think about it, you could have a repeat of all of this code pretty much for each model, for each cost, but this creates sort of a general solution. It's called generalization. So it reduces repeated code. We don't want tons of code that's very, very similar. We'd rather it be in one general solution. It's also easier to update or change because it's sort of contained within a single function block. I've done block in quotes because it's not really a technical term, but this also makes it easier to test. I'm not going to write that as an answer, but it could be an answer. Easier to test because you can just execute this one block of code. You copy it and paste it into something else, test it in isolation. A third advantage, which is maybe, I wouldn't say harder, but it's maybe not as obvious, is it makes it easier to code as part of a team. A lot of this actual course is talking about sort of big team projects, isn't it? About the software development lifecycle and things like even prototyping. So it makes it easier to code as part of a team. So you'll definitely be aware of what I mean by this. This is called decomposition. You might not be aware of what it's called, but just the kind of general idea of splitting a task up into smaller bits. So you try and solve a difficult problem by splitting it up into its individual parts. And when you're coding, this could be just your general task, and you split it up into different subroutines. So this could be a function, this could be a procedure, this could be a function, and it could just be tackled by someone else. And it makes it a lot easier. You kind of have these modular components to your programming task, and it makes it a lot easier. So these 3 points are on the mark scheme, fortunately. Also some other good points. It does say testing as well. Makes it more elegant and understandable. This is also called readability. Makes it, pre-written routines. So I said subroutines, but also routines is the same thing and can speed up development time. So a lot of them are similar. It's difficult again to think of 3 distinct advantages, a bit like earlier. So it's not ideal, but hopefully you'll get 3 marks. Question 8 is another quality of written communication essay type question. It's worth 6 marks, and it is to discuss the advantages and disadvantages, and as importantly, you can't just talk about one or the other, of connecting a computer to a network, and as I say, quality of written communication. So I just want to show you the examiner report here. This is really interesting because it says that only 5% of candidates got 4 marks on this. I know it's a 6 mark question, so it's not incredibly easy, but that's not, it's not, suggests this was just people didn't understand it really, which, I don't know, it seems quite simple, but they've said that people just kind of reverted to talking about network topologies and the 3 types, but this wasn't the question. So they say this points to a need for candidates to practice exam technique more deeply. Well, really, this is just reading the questions, so there's no point spending 6 minutes writing about topologies, but it's got nothing to do with actually just the fact of connecting a computer to a network. It's not about network topologies or how they're arranged, it's about just connecting a computer to a network. So advantages, do my little spider diagram thing. So first of all, you can share resources over a network. So like resources are things like printers, allows communication, especially over long distances. When I think of a question like this, I'm thinking more of a business rather than perhaps home use. It does apply, but also networks allow people to back up data easier. So you can connect to a server which can back up your data in kind of a centralized location. There are others, but I don't really want to spend too long thinking about it. So the most obvious disadvantage to connecting to a network is it makes you more vulnerable to security risks. I want to say potential security risks because you can obviously reduce the risk. Security. And so this would be things like viruses and hacking are the 2 main categories you might want to talk about. Also the cost of connecting to a network. There's certain hardware you need, like a switch, like a router if you want to connect to the internet. So this is to do with cost and also any expertise. So like before, I'm going to write this up. I'm probably going to split it up into 2 paragraphs, just for one for advantages, one for disadvantages, just to make it a bit nicer, maybe get those quality of written communication marks. So I'll do that right now. Okay, as you can see, I've done a paragraph for advantages and a paragraph for the disadvantages. Just to split it up, it might be quite a good idea. Again, it's not an incredible answer, not very interesting or inspiring, but it's there to get the job done. Hopefully I'll get 6 marks in the exam. Some extra examples that I could have written about are things like you can work from multiple locations, create more resilient systems so you're less reliant on one computer, processing can be distributed, easier monitoring in a business or school maybe, and disadvantages, hardware failures can impact other devices, and you could be limited by like the speed of the network, perhaps that's what that means. And to get 12 marks you need to do 2 or more disadvantages and advantages, so 1 of each at least, and obviously good quality written communication to get the 5 or 6 marks. So we can move on. Question 9 is appropriately worth 9 marks. So this is the longest mark part of a question, or this is just the whole question in the paper. And this is the algorithm question. Some people probably dread this, some people would really like this. And in this scenario we are told that an English teacher wants to estimate how long it should take his students to read a book. You've been asked to develop an algorithm to calculate this estimate, and they must do the following. So helpfully they've broken it into bullet points. I imagine the question you'll get in your exam, you're bound to get a question like this with worth a similar amount of marks, and they're probably going to break it down. So this is really helpful. You know, they're not leaving it to you totally. So you first of all got to ask the teacher how many pages the book has and store this in an appropriately named variable. For each page in the book, the algorithm should ask the teacher if the page looks easy or difficult. If it's difficult, then the total number of seconds should increase by 100. So when you're reading this, you should be thinking, well, we need a variable for use the input. We have to have a variable for seconds too. If it's easy, it should be increased by 40, so just a lesser amount. Then after it has entered the difficulty level for all the pages, it should output the estimated number of seconds. So we have an output, we have an input first, we have an output, and for every page, so we're going to have to loop through the book, which seems very tedious for the teacher. We then have some if-else statements, so some case conditional statements that actually ask and use his decisions. So you can do this in 2 ways. You can write pseudocode or draw a flowchart. I'm going to do pseudocode. Personally, my personal preference would always be to do pseudocode. Some people would much rather do a flowchart, but I think pseudocode is definitely more appropriate. So I've just done this on paper. It didn't take me that long, to be honest. This isn't the hardest question I've ever seen. There are some questions like this in GCSE papers which take me a while to get, but this is not the hardest, if I'm being totally honest. So first of all, let's just follow the order, which is the right order. So we have to do a input. So this is how I would do it. The good thing about pseudocode is it's not, it doesn't have to be the same for everyone. So input is a keyword, and we need to assign this input to this variable pages, and I'm just gonna, this is about unnecessary, but I'm just gonna say something like how many. So we now need to do our loop for every page in the book the algorithm should use. So there's 2 kind of loops I was considering to use, for and while. I tend to use for when we know how many times we're going to be looping, so that's called a definite loop. But in this case we don't actually know how many times we're looping because we're looping based on this input of pages. So you could use while, we could use for, it doesn't actually matter, but I chose to use for some reason, so I'll stick with that. So the way I'm going to do is I'm going to use this the counter, coincidentally the same letter. Often you'll use X instead, or I, doesn't actually matter, so we're using it as a similar purpose to earlier. So for I equals 1, 2 pages is my opening line. So what I've done here, basically we're starting with I as 1, and we're going to increment this each time it loops until we get to pages. So say this was 100, we're going to be going from 1 to 100. You could do something like repeat pages number of times or something along those lines, but this is how I've chosen to do it. We then need another input to asking the teacher if the page looks easy or difficult. I'm going to call this difficulty. I'm going to do it in different colours to make it a bit stand out a bit more. So we now need to ask the teacher for another input, so if the page looks easy or difficult. So again, I'm going to use another variable for this. So I'm going to go difficulty, this is what my variable is going to be called, equals input. We need to be consistent with our conventions. Let's say, is it easy or hard? So this bit doesn't actually matter. This bit here and this bit here doesn't actually matter. This is just something I'm envisioning is going to get shown to the user just to explain it. But you could just write input, to be honest. I've changed it to difficult because that's what it actually says. I'm now going to do an if statement. I'm going to keep it in this orange colour just to show the main body of this for loop. So let's do if difficulty, so this input we've just had, equals difficult, and I'm using double quotes for a string, then seconds equals seconds plus, so what is it when it's difficult? It is 100. So seconds equals seconds plus 100. This is quite an important line. Coming back from what we were doing earlier, where when you write it in this format, we're basically saying we're using a previous value of seconds, which at the moment, in fact, that's a very good point. So what I've missed out here is we need to actually have another variable at the start being initialized, and we're going to initialize it to 0. So let's do seconds. So I completely missed it out. So seconds, it's because it doesn't actually say. So this is a good point. Make sure you adapt your code. Don't just be static. Don't just be going through it. If you need another variable, make sure you write it in. So you need to this line because otherwise it's not being initialized. It will not. In some languages it might be okay with this, but in other languages it might not be. Although this is pseudocode, so it doesn't matter so much. So I'm then going to do, if it isn't difficult, then it's going to be else, which is going to be easy. We've only got two conditions here, so it doesn't matter too much. Else seconds is going to be same as seconds plus what is it, 40? Yeah. I'm then going to do an end if line. My convention is being very similar to the AQA. I've got the AQA thing up on my second screen, the AQA pseudocode convention sheet, so I'm somewhat copying it. You can see I haven't been doing the variables as like a little arrow, just out of personal choice, just to make, mainly to prove a point that it doesn't actually matter too much what convention you use. You can write it out more than I have, you can make it more programming like than I have, doesn't matter so much. You might also want to indent bits of it, just to show you the sort of layers of scope, but again, it's up to you. But this does come to the end of our for loop. I'm going to write just end for. It's always good to close your loops. So what have we got left? We've asked them it's difficult. The number of seconds will go up by 100. If it's easy, then it'll go up by 40. Just to re-emphasize why this line is important here, and this line, we're looping. So if we just if we did seconds equals 100, it's just going to keep replacing this variable as 100 every time it's looping through. We want to use a previous value for the loop. The first time it iterates, we're just adding to 0, but then we're going to be adding to a previous value for each page. So that's why this line is really important. I just wanted to emphasize that. So I need to do an output line. I'll do it in green just to follow the pattern. So yeah, we're not saving to a variable each time. So this keyword, which I'm capitalizing, again, I'm just going to do a little message. So the estimated num of seconds is seconds. So this bit doesn't really matter so much. As long as you could just write output seconds and that would be perfectly valid. So I'm now going to mark my own work, which is risky. Hopefully you can see this. I made it a lot smaller, so hopefully maybe watch it in full screen if it's got a bit small. So you get a mark for assigning user input to a variable, so we've done that here, this line here. One mark for creating a variable, it stores the number of seconds. I've done it here, I've put it at the top. A mark for using a loop to iterate over every page. But as I said, there are many logically equivalent ways to accomplish this, and I've just done one of them, so this is this bit. A mark for asking for user input for the page difficulty, another input line here. Or a mark for using selection to decide if the input is easy, or yeah, so it's kind of, I've done the converse of what they've said. So but I have done this selection. I've used else in this case for when it's difficulty, when it's easy. Selection within the loop, yep, so it is in the loop. Increasing by 40, increasing by 100, and outputting it. So this is our 9 marks, so that's good. It's always a relief when you get full marks, especially when you're making a video on it. So I can now show you the exam board have helpfully done this for me. Other examples, so feel free to pause. I don't want to talk through all of it, so I've just done a repeat. So I think I said you could do this, which is perfectly valid, instead of using a for loop. Pseudocode, I don't know many languages that have a repeat loop, but this is pseudocode, it doesn't matter so much. They've indented all of their things, it's not actually necessary, it could be up to you, it makes it look a lot nicer certainly. So this is a similar one to what I've done, in fact it might be very similar. They haven't done any of the fancy outputting or inputting, they've just done user input, output, but it's the same thing. And also, so you could do a flow chart. I said that I personally wouldn't do it, and this is kind of why. It looks very complicated to me, certainly. I'll zoom out so you can see all of it. Yeah, I personally wouldn't do it. It looks very complicated. You're still writing things in it, so this parallelogram is for user input, by the way, and it'll be the same for output too. So I'd personally, I think with pseudocode would be a lot easier, but that's down to you. Just look at the examiner report, which is always useful for things like this. Some things they've said, they encourage people to be more explicit. So pseudocode, you can be quite relaxed, but not too relaxed. Don't say increase time by 40, because I mean it's not very programming like. It's better just to say kind of what we did, except they're using their little arrows for the assignment. Basically, some candidates decided to declare functions, which is not a brilliant idea. It's a good programming practice to do this, but not in an exam unless they specifically say. So if you get if it says specifically to do a function, do a function. If it doesn't say it, best not to, because it's going to make it more complicated for you. Although if you did manage to get the answer using a function, that's quite impressive. So the final question of this paper starts by telling us a built-in function can be found in programming languages, one that finds the character in a string at a specific position. And in some programming languages they say this is called character at. And so with parameters string, str and I, it returns a character found in position 1, position I of a string. So for example, ABC is our string, and when we have 1, the first position is A, and same when it's the third position is C. So this is what it does, and we need to just do a bit of practice for this for AQA. So our function will be returned by a function called character at hello 5. So the fifth letter in hello is 1, 2, 3, 4, 5, so it's O. Nice easy mark. And similarly, we now have to actually evaluate this argument. So 3 plus 1 is 4, so we're now looking for the fourth character in goodbye. 1, 2, 3, 4, so it's D. If we're being pedantic, it would actually be with quotes, but that doesn't matter so much. Question 10b is worth 6 marks, and it's about completing a trace table. We've got a lot of information and obviously code before that. So a palindrome is a string that is the same read forwards or backwards. So for example, ABBA and ABCBA are both palindromes, but ABCBB is not. And it uses this function we've looked at, and it also uses the len function, which returns the length of a string. So we have this code in pseudocode, and we need to fill in this trace table. So we've done a trace table earlier, so this is going to be slightly harder, I believe, but same kind of idea. So first of all, when we input is ABC, ABA, so this is not a palindrome. We can see that, but that's not really the point. We need to fill it in ourselves. So it's done the first bit for us, not the first line. So we've done the input. So the input of str in is our input, which is this string. So then we have is palindrome true, so automatically we assume it's true. We then have the variable I up is 1, so we can fill that in. We then have I down as the length of str in, and this is 1, 2, 3, 4, 5, 6. We're doing this in the same line because it's all part of the same process. We don't do a line per line in the code, it's sort of part of the same process. Hopefully you'll see what I'm doing as I go through it. We then have a loop, so if I up is less than I down, so it is at the moment, 1 is less than 6, we then have an if, so we have some selection. So if character at string in I up, so I up is now 1, and we've obviously got string in as this string, is not equal to, this means not equal to, the same with I down, so this is when we've got 6 here, then is palindrome because false. So let's try this. So the character in the first position of this string is A, so let's just write this here. The character in the sixth position is A, and it says if it's not equal to, then, well, it is equal to, so we skip this bit and just go to I up is now I up plus 1, so 1 plus 1 is 2, and then I down is I down minus 1, so 6 minus 1 is 5. We then go back up to the while loop, so when I up, which is currently 2, less than I down. Well, it is, so we still do this bit. We then have I up as 2 and I down is 5. So second in ABC is B. The fifth is also B. So this is not equal to, so we also skip this bit. So I up equals I up plus 1, so this is now 3, and then 5 minus 1 is 4. And you can see that nothing is changing with our first two columns. So we then go back, I up is still less than I down, so we now have I up is 3 and I down is 4. So the third character is C, and the fourth character is A. So when they're not equal to, well, they are not equal to this time, so now we set is palindrome to false. And that's it, because we've now ended our loop, because finally I up is greater than I down. If it was still less than I down, we'd repeat again, but we've found our final answer here, that it's not a palindrome. And we've got this extra line here. This is here to not put you off, but I suppose if you made a mistake, it gives you a bit of room, but we don't need to go into the extra line because we're done. The final 2 marks in this paper are about errors. We're told a programmer develops a program from this algorithm but mistakenly types "like" instead of "while" after in line 5. Take the type of error that has been made. Well, this is a syntax error, so the syntax of the language. So this is part of the syntax of the language. The syntax is kind of for general rules of a language. So in a way, like grammar is for English, they're not totally the same, but we can liken it to that. So we're basically, it's like a spelling mistake essentially, and so the code won't execute because it won't be able to understand what "like" is because it's not in the instruction set. So it's a syntax error. The programmer has now made another mistake and types a greater than symbol instead of a less than symbol when implementing line 5, and tick the type error that will occur when programmers run. So this is, I guess, trying to throw a little bit, because you might think when a programmer's run, okay, they're giving me a hint, it's a runtime error. Well, it's not a runtime error. They haven't said runtime here because it won't actually run, because you can't run when it's got a syntax error, but it will still run. It will be a logical error. The logic will be changed because it should be a less than symbol. The logic, it will still run, but not in the way the programmer expects. So that's what a logical error is by definition. Okay, so this now brings us to the end of the paper, so the end of this video too. Just some general advice for the exam. Make sure you, first of all, keep referring to the exam board specification. This is what's telling you what is going to come up, the topics they can examine you on. And this was the first course that I made on my channel, and I actually bought the textbook for this, the official endorsed textbook, which is absolute rubbish. There's nothing, the amount of stuff not in that textbook and the amount of stuff that's included in that textbook, which is rubbish, is awful, really, if I'm being totally honest. So don't use the textbook, or don't assume that everything in the textbook is going to come up in your exam. Use the specification. Some stuff in the textbook may be useful if you have it, of course, but be very careful. Research stuff if it's on the specification but you don't know it. Make sure you look it up, even if it's the night before the exam. For GCSEs at least, revision the night before the exam can work really effectively, so bear that in mind. Hopefully my videos will be useful. They might be good for sort of night before the exam type things. They're mostly quite short, so I used to do all the past papers again, even if it's the night before the exam or the morning before, whatever. In fact, no, it's a morning exam, so ignore that. Do all the past papers. There's not that many available. There's 2 official ones, 2015, 2014. I think there might be 2 samples, 2 or 1 sample. So do all of those. Look at the mark schemes, look at the examiner reports if available, and hopefully you'll do really well. So good luck.